Well, hey, fan addicts, Charlie and Ned in here, coming up on our second episode. So, welcome. And today we're going to be talking about doing some fan basics, some fan ABCs, and help you guys understand how they work and what they're all about. So, yeah, let's get down to it.
Yeah, let's do it. Glad to see you all back. So let's just dive right into it. I'm just curious, what is an axial fan for the people at home who do not know what a fan is?
Good question. So, got a couple of parts here sitting here handy for us today. So, an axial fan, and the whole reason I didn't even know why they were called axial. It was probably more than 10 years into my career and somebody asked me why do you call it that? And I'm like, I don't know. So what it is it's the flow of the air. So you have the axis of the fan is here, right? Right in the middle.
Hmm.
So the airflow is going down the axis of the fan. So that's why it's axial.
Interesting. That actually
So,
makes a lot of
you
sense.
might say, okay, well, what else is there out there? And we'll hit on this probably next week's episode. We'll talk about blowers, but they're considered radial. So, they disperse the air in a different fashion than down the axis of the fan.
Right. Yeah, that makes complete sense. And then I understand there's actually multiple bearing types in a fan like that. Can you elaborate a little bit more on what that means and what those are?
You bet. So, the bearings are definitely one of the most important part of the fan as it determines the reliability of the part. Right. And so you say, okay, well, why don't you just make the best one all the time? And it's like, well, you different people have different needs for reliability, right? Reliability meaning how long they last. But, it's a like type of thing where if you're designing a product that you only want it to last 1 or 2 years, why pay for a 10-year fan?
Hmm.
Right? So that's the reason for having different bearing systems for different reliability needs. So you kind of have your entry level sleeve bearing, right, which is super common. It's your lowest cost part. We can have a little image here that shows you what the sleeve bearing's all about.
Hmm.
Those are typically rated in the 20,000 hour range. Um, One thing about sleeve bearings is that you definitely want the fans mounted vertically. And when we say vertical, that's having your fan mounted like this, right? So where the axis of the fan is parallel with the ground,
Hmm.
right? And we say that because, you can have, if you're laying down, right, gravity is naturally going to draw the lubricant out of that bearing.
Right.
And, old school days back in the 90s, right, you get your fan, you hear it squeaking and making noise. That's your sleeve bearing that's dried out.
Hmm.
So sleeve bearing, low cost, 20,000 hours, mounting sensitive, right? You only want to mount them like this. Um, but then if you want to get into like a 50,000 hour fan, 50 to 60,000 hour,
Right.
we have a hybrid sleeve and it's called our Syntetico. We've got a little drawing here that you can look at and show how this system is set up, but it's a fancy sleeve bearing made out of better materials, and we can get into a technical conversation about that sometime where we break it all down, but in simple terms for today, one side is sealed, the other side is a nice washer system so that it doesn't leak, right? And that enables us to get to those 50 to 60,000 hours at 40C, right? And by the way, all these come with cost either increases or reduction, whichever way you're looking up and down the scale. So sleeve bearing being the cheapest, Syntetico is being middle of the road. It's considered a hydrodynamic bearing.
Hmm.
And then you go up to ball bearing, right? And so I know you guys probably won't be able to see this, but I got this little bearing here. It's kind of like what you would put in a skateboard wheel
Right.
or something like that, right?
Little
So,
bit, little bit smaller than a skateboard wheel.
yep. But these guys, there's balls inside of this. It's impregnated with grease. This is your highest reliability solution in the 80,000 hour range, right? But it's going to be your most significant cost.
Definitely.
Right. So when you go from ball bearing to Syntetico to sleeve, it's almost like you can see in the ballpark, shooting from the hip, 20% reduction on each
I
change in
see.
bearing type.
Wow.
So um, so yeah, so bearing options. So that's why sometimes when we come in and we sit down and we're talking to you, it's like, hey, what are your reliability needs? Right? Or what is the application? Because sometimes you can have a different bearing system that would be much more applicable, like in a high vibration application, right? Ball bearings can get beat up, right?
Hmm.
Syntetico can be better,
Hmm.
right? Or you get into a very corrosive environment, right? You might not want standard chromium steel ball bearings because they can rust,
Right.
right? but we've got all kinds of cool tricks that we can do. And that's why we say modified standards, right? We can come back, give you some basic adjustments to the part, and make it more reliable for the environment that it's in.
That's
Because what do we
huge.
say? One
Modified
size
standard.
does not fit all.
That's true. One size does not fit all, and we will modify our standards.
That's right.
Yeah. So I want to ask you about different speeds on our fans. Do they come in different speeds? How is that? How does that work?
Yeah, so, fan speed is controlled by the motor windings, right? So we do have very specific speeds that fans can be in: low speed, medium speed, high speed. That's in our catalog. We've got all those different speed levels. So that works out great. Now you say, okay, that's fine and dandy. I get my fan, I've got the CFM that I want, but that's like at max conditions, right? And it's like, so if the system's not 100% use, it's not up, and I want to slow it down so I don't hear it, or I want to save energy,
Mhm.
right? We can definitely do that. So there's really two ways of doing it today. Either voltage variation, right? So that means if you have a 12-volt fan, you can come in, you can reduce the voltage within its operating range, which is typically down to like 6 volts, right? And that's going to slow the fan down, right? That's how people have done it forever. It's your most basic means. Now, when you're doing that, though, you have to do pure voltage and not chopping of the voltage, right? And so what I mean by that is, like, we can do PWM parts,
Mhm.
right? But we have a bona fide PWM input wire to where you're inputting a PWM signal down that wire to control the fan, right? That is the most ideal. It's the most detailed to get exactly what you want. And there might be people out there saying, "Oh, well, hey, check it out. We can PWM the voltage." Well, if we were having this conversation 10 years ago, I'd agree with you, and that's cool. Um, for argument's sake, we'll say that that was possible on a analog IC. For YS Tech today, all of our fans are digital, right? So think of it this way: if you're switching the power on and off on the power going into the fan and you have a digital IC, it's going to malfunction because it needs constant voltage to operate.
Mhm.
So all kinds of cool options on there on how we can really utilize the speed control, right? And if you're not sure, that's where we engage and talk about it.
Definitely. That's the way to do it. Okay. So thank you so much. Just wanted to ask you about how would airflow and pressure factor into the conversation about axial fans?
Yeah, so we'll definitely have an episode where we can get into that because that's a whole conversation in itself. But think of pressure as when you have a fan blowing into your device, right? And
Mhm.
let's assume it's something like the size of a shoebox or something, right? So if a shoebox is like 2 cubic feet of space, right, and you have a fan blowing 10 cubic feet of air in there a minute, at a certain point that box is going to be pressurized. So system operating point or static pressure is the curve of the fan that tells you what the fan is going to do when it's under pressure. So, it is very important to understand that, and that is one of the most difficult things to identify. But in future episode, we'll look at like CFD work, and that is a service that we can provide that will actually enable us to tell you what the pressure is in your system, so that you can know exactly what your operating and flow rates are.
Oh wow.
So that's what it's all about, really, when you get down to it.
Perfect. And then I wanted to ask you, I know there's a lot of different fans on the marketplace, and you touched briefly on why our different fans are so reliable. What is it at its core that makes YS Tech fans so reliable and last for such a long time?
We get into looking at what industry specific needs are, the verticals that we
Hmm.
cater to. And whether we're talking about industrial applications or medical applications or automotive applications, is we're getting in and looking at the specific needs and the things that are difficult within those environments. So, like, if, for us as a company, automotive is one of our biggest industries globally. And, when you sit down and you look at a part, we address things like over voltage, right? It's like a
Hmm.
vehicle operates at 13.8 volts, right, on a gas car. There's high temperatures, right? If you live in the desert in Arizona and Texas, hot places in the summertime, your car's bacon, in the heat.
Mm,
And so by addressing the things that are the reliability concerns, board level components, bearings, lubricants, like all these things, we can do these upgrades that are industry specific. And that's what helps improve the reliability and consistency of the product over time.
that's huge.
Yeah.
Yeah. And then I wanted to ask you, in terms of YS Tech planning for the future, what are some things that we're currently doing to better YS 10 years from now?
So we're continually always upgrading our parts, right? So when you get into the board level design, there's always new components and ICs coming out that enable us to lower current, make them more efficient. Having microcontrollers and fans really helps with the type of technology that we can package in the device and not have to have the customers providing from an external standpoint. So we're always looking to try and improve the electronics within our part. We're always looking at growing the mechanical design and the performance. We've got a couple of very interesting fans for the PC and gaming world that really are addressing um, sound quality, and you know it's the products are always underway and always under continuous improvement. And then when we're talking about us as a company and how we continue to grow, we're currently right now, we'll show you a picture right here, opening our new headquarters and moving in literally over this next month. So this is our seventh facility, or no, sixth facility. We've got three facilities in China, now three facilities in Taiwan. So, and of these three, they've been added over the last 4 years. And we will be looking at our seventh facility. We're looking outside of China right now. That's a big thing in our industry. So we are looking at Thailand and Vietnam, and those are some things that we can be talking about in future episodes as well.
Definitely. Yeah. Well, I think that that's a good enough amount. Do you have anything you want to add in, just a
Yeah,
touch?
no, I mean, if you guys are looking for additional details on the fans, we're always happy to share. There's so many things about them, and we can get into greater details. But as we get going, and if people are seeing it and you got comments, you can always ask us questions, and we're happy to get back to you. Or
100%.
just reach out to us on email. And, if you wanted some samples to evaluate or look at things, that's the whole point of doing this, and we're happy to hook you up.
Yeah, and feel free to reach out to us on other forms of social media. We've got X, Instagram, LinkedIn, YouTube, which you guys are probably watching this on. Just reach out to us if you have any questions. We're happy to answer it. Hey guys, stay addicted. Thank you for tuning in this week.
That's right. We'll see you next time.